Alright, so before you actually draw this picture of a pendulum, just look at the different parts I want to point out need to be in your drawing. You have a ceiling here, and maybe a hook attached to the ceiling, a string hanging down, and we're going to see that the pendulum, we're going to look at 5 different positions. Alright, we're going to look at position A, where we're going to say somebody's holding it. Alright, so it starts at rest there. Write that in. And we're just going to look as it swings a half of a period, a half of a cycle, where it goes from A to B to C to D to E before it turns around and goes back, all right? So you could press pause now and copy that picture down. All right, so now that you have it copied down, I want to look at this idea of conservation of energy of the GPE and the KE. So when it's lifted up, a hand lifts it up to letter A and holding it there, it's at rest. Okay, so let's look at GPE first, though. Because it's lifted to a certain height, it has GPE there. All right, so we know it has a height, so it definitely has GPE there. It's above the ground. Now as it swings down, it gets lower, so it actually loses GPE. So I'm going to write GPE smaller letters because there's less of it. So it starts with a lot of GPE, now there's a little less GPE, but it still has some height above the ground, so it still has a little bit of GPE. And here at letter C, we're going to basically see it's almost at the ground. So we're going to say no more height, no more GPE. All right. Now as it raises back up, it gets more height though on the other side. So it gains back just a little bit of GPE. And then as it keeps going up, more height means more GPE. So the higher it is, the more GPE. At A and D is where it's the highest, so that's where it has the most GPE. And as it gets lower, like at B or D, or at letter C especially, it has the least amount of GPE. So what does that mean? All right, for kinetic energy, all right? Well, here it starts at rest, so there is no kinetic energy there because you're just holding it. It's not moving, so it has no kinetic energy. But it starts to speed up a little bit from A to B. As it goes down, it gains a little bit of kinetic energy. It has kinetic energy at B. But at letter C, it goes down even more. So it speeds up even more to get to letter C. So at letter C, it has a lot of kinetic energy. All right, and then it rises up to letter D. It's like it's going uphill. It slows down a little bit. But it's still moving, so it still has some kinetic energy at letter D. And then at letter E, before it turns around, for a moment, it comes to rest for a moment before it turns around. So it doesn't have any kinetic energy up there. But what we could see and what we want to focus on is the fact that when it has a lot of GPE, it has very little kinetic. As it loses GPE, it gains more kinetic, and as it loses more GPE because it's lower, it has the most kinetic. It gets even more. And as it rises up, it's going to gain GPE back. It's going to get more GPE, which means it'll have less kinetic. And as it rises up more, it'll gain even more GPE and then have less kinetic. So there's this relationship where when GPE goes up, KE goes down, and vice versa. And the reason why that happens is those two always need to add up to make the same number. When you add them up, you get a total, and that total has to always remain the same.